Now we see the two systems that we looked at previously. Here's another system that's very similar to the first two. The only difference is I've changed the sign of the 8 here. So I've got 4x minus 8y equals 24. Okay, well, you can think that, yeah, okay, that's going to change the slope of this line. So if we graph the lines, they're going to probably intersect. They have to intersect if they're not parallel. If we change the slope of this one without changing the slope of this one, since this one was parallel to this one, it ain't no longer, and therefore we are going to have an intersection. We'll see how that works out with the equations and with the augmented matrix. So we just do the row operations. As before, we subtract 4 times the first row from the second, or 4 times the first equation from the second, and we get this, or we get this. And then we divide through by negative 16, and we find that y is negative 1/2. Over here, we multiply the second row by negative 1/16, and this stands for the equation no x, y equals negative 1/2. At this point, we can back substitute and find x, but that's not what we're going to do. We're going to continue eliminating variables from these two equations, or continue reducing the matrix. And it's very straightforward to do that. We simply add double this, or subtract double this equation from this one, and that takes care of our 2y. And that our negative 1/2 will be a plus 1, and add that to 4, we get a 5. Or we take negative 2 times the second row here and add it to the first, and we get this. In both cases, we find that x is 5, y is negative 1/2. Either way, that's our solution. If we were to graph the two, and I did, I found the intercepts, very easy to do, graph the two and locate our point of intersection on the graph, and it was, hand sketch graph, reasonable. It's very plausible that this point is 5, negative 1/2. X-intercepts are 4 and 6. This is about halfway between, a little too far that way. Negative 1 is here, y equals negative 1/2 here, very plausible. Okay, so we draw some conclusion about our reduced matrices. Okay, if our reduced matrix has a row like this, zeros followed by a number that's not 0, it's no solution. It means our lines were parallel. If we have a row of zeros, that means the equations were multiples of each other, meaning they really were just different representations of the same equation. If you solve them both for y, you get the same thing. So that our solution is every point on the first line, or every point on either line. Okay? Infinitely many solutions. Okay. Now, we take a look at the reduced matrices again and just summarize what was said. Okay, if here's your reduced matrix, then 0 not being equal to 8, you have no solution. Lines have to be parallel and non-intersecting. So when you see this case, you know all those things are true. I mean, it's not necessarily 0 is not equal to 8. If you continue reducing, you're going to get 0 equals 1, because you can divide this by 8, right? In this case, 0 equals 0 is fine. Solution is x plus 2y equals 4, which is what this equation tells you. The whole line, infinitely many solutions. Both equations give you the same line. Okay, in this case, we reduce to an equation, an augmented matrix that's equivalent to the equation x equals 5, y equals negative 1/2. So there's exactly one solution. X is 5, y is negative 1/2. The lines intersect in exactly one point. Then we looked at a series of matrices here, and I'm not going to comment on this. If you don't understand this pattern completely, you should look at these matrices in the order they're done in the longer videos.